Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Counting Sum Lines by Mimic, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We also have box borders divide each blue line into segments with the same sum. And these are usually known as region sum lines. So for example, here, these 2 digits must add up to the same sum as these 5 digits, which must add up to the same sum as these 3 digits. Same with every other line here. These 2 digits must add up to the same sum as these 2 digits, which must add up to the same sum as these 2 digits there. So as an example, we could have something like 5 and 7 and 4 and 8. And that would be valid because 5 and 7 add up to 12 and 4 and 8 add up to 12. And those are the different segments on this line. Different lines may have different sums. A blue circle indicates exactly how many circles contain that digit. For example, if there is a 4 in any circle, then exactly 4 circles contain a 4. So we could have a 4 here, a 4 here, a 4 here, and a 4 here. And as long as the other circles did not contain 4s, then this would be valid for the 4s at least, because we would have 4 4s in those circles. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. First of all, how many circles do we have? We have 2, 4, 6, 7, 8, 9, 10, 11, 12. We have 12 circles. So the digits in the circles must add up to 12. Because you would have 1 1, 2 2s, 3 3s, 4 4s, 5 5s in circles if you had all those circles. So all those digits must appear that many times in circles. So therefore, you have all the digits in circles must add up to 12. Also, we know there are at least 3 distinct circles, three distinct digits in these circles, because we have 3 cells here, or 3 cells in column 1, which all have circles in them, so there have to be at least 3 distinct digits. So the possible combinations are 129 for 3, 138, 147, 156, 237, 246, or 345. Those are the possibilities for 3 digits. For 4 digits to add up to 12, it's 1236 or 1245. Okay. We have these region sum lines. This digit has to be 6 through 9 because it's a sum of 3 unique digits. That's interesting. Because so the sum of 3 unique digits is at minimum 1, 2, and 3, which adds up to 6. It could be up to the largest digit being 6. But if this were 6 and this were 9, the problem with that is that that would add up to 15 already. Because we would have to have 6 6s in the circles and 9 9s. So this cannot be 6 here. Can we have 5 here and 8 here? That's not possible because 5 and 8 already add up to 13 with 2 digits. We could have a 4 here with a 7 there. That is possible. And then the last digit being a 1. So this digit is 6 through 9 there. We have another digit here, adding up to 3 unique digits. So this is 6, 7, 8, 9, and 1 through 6 here. And I think, yeah, you cannot have 2 unique digits from 6 and 7 ever adding up to less than 13. And we have only 12 circles here, right? 1, 2, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So these digits must be the same digit. So this is the same digit as that. Actually, let's make it red. This is the high digit. Here we have 4 digits here. So in column 9, the whole region sum line is in that column, and we have an extra digit here. First of all, this is the red digit here. So this cannot be the red digit here. So it cannot be 6 or 9 here, essentially, if that's the case. Now, the reason why I was thinking of that is, what is this, like, what are exactly... So the sum of this line as a whole is going to be equal to a sum here, and a sum here, all being the same sum. So it must be equal to 3 times a number, right? Which is the sum. That means it's going to be a multiple of 3. And we know these 9 digits add up to 45. So for this total line to be a multiple of 3, we can only add another multiple of 3, right? 45 plus 3 would give you 48. 43 plus 6 gives us 54. And 45 plus 3 is 48. 45 plus 6 is 51. And 45 plus 9 is 54. And those are the only multiples that would be divisible by 3. Those would be the only numbers divisible by 3. So we're guaranteed this has to be 3, 6, or 9. But, again, if this were 6 or 9, the problem is we'd have 2 unique digits in circles which are 6 or higher, which guarantees that there would have to be at least 6 and 7 in them, which means we'd have to have at least 13 circles, which is not valid. So, this cannot be a 6 or 9. It has to be a 3. That means this cannot be 3 here, so this cannot add up to 6, because this cannot be 1, 2, 3. So this can't add up to 6. So this has to have a 2 here. It's either 1, 2, 4. Actually, it has to have 1 and 2 here. It's 1, 2, 4, 1, 2, 5, or 1, 2, 6 here, adding up to 7, 8, or 9. So we know these add up to 48, which is 45 plus 3 divided by 3, which is 16. So this adds up to 16, this adds up to 16. Now the interesting thing is 2 of these digits cannot add up to 12, right? We know we have 3 unique digits here and the circles adding up to 12. So this adds up to 11 at most here. Well, to add up to 16, that means this digit has to be at least 11, or at most 11. And we know that this digit... So actually we know, okay, we have the guaranteed 3 here. That means the other 2 at least unique digits, we can either have 2 unique digits adding up to 12 minus 3, which is 9, or 3 unique digits adding up to 12 minus 3, which is 9. That means we can never have a 9 here. So we have a guaranteed 7 or 8. So that means we have to have 3 unique digits adding up to 12. right? Because if you have 4, you have the largest digit you could have is a 6. 1, 2, 3, and 6. But we guaranteed cannot have a 6 here because we can't have a 3 here because of 3 in the column. So this is either going to be 138 or 237 adding up to these digits. So we can't have 4 here. So one of these is going to have to be 7 or 8. We don't know which. This has to be... Okay, so these are the sum of 2 digits. It could add up to 17. So again, in the circles, we have 1, 3, and 8, or 2, 3, 7 adding up. These two digits must be equal to the sum of 5 digits at least. So we're guaranteed this has to be a 7 or 8 and is the red. And these 5 digits... Okay, so if this is the same as that digit, that wouldn't work. Because we would have 4 digits here adding up to the same sum as this digit here, which is not valid. So this has to be 1, 2, or 3 here. This is 1, 2, or 3. This is 1, 2, or 3. Where is the 7 or 8 remaining? It has to be here. So we know this is 7 or 8, and one of these is 1, 2, or 3. Sorry, one of them is 3, I should say. This could be 7 or 8. Can it be 1, 2, or 3? If we had 1, 2, or 3 here, that would be at minimum 3 and 9 adding up. This cannot have a 6 anymore here. Neither can this. Seven or 8 has to be one of those two. Obviously, could very well be that one. Cannot be here. It's one of those. Cannot be here because of the 7, 8 in the column, so it's one of those two. Okay. So again, what are these possible combinations could add up to 11 at most. Can you ever have 1 and 3 there? Or 2 and 3? No. 2 and 3 at most adds up to 5, which 5 plus 11 adds up to 16, but 11 is not a digit. So one of these is guaranteed to be the red. That leaves the red guaranteed to be one of those two here. 16, so it could be 16 minus 3 and 8. That would be 11, so this would have to be 5 in that instance. But if that's the case, okay, so this cannot be 3 and 8 here. So if the red were 8, this would be 8 and we'd have 1, 2, 5 there. And then 3 and 8 would not add up to 5. So 3 and 8 doesn't work. The only other combination with 8 would have to be... You can't have 1 or 2 here. So we know this is guaranteed to have a 3. So again, if we try to have 3 and 8, the problem with that is that would guarantee this is 5 to add up to the same region sum as this. Because this is 45 here, plus 3 is 48, divided by 3 is 16. So each sum is equal to 16. 3 and 8 is 11. 16 minus 11 is 5. But this can no longer be 1, 2, 5, adding up to 8. So this cannot be 8. It must be 3 and 7. So these are all 7s. as the largest digit. And this must be 1, 2, and 4. So this has to be 2 here. That's 3. And this is 1 and 4, adding up to 7. And this is not 5. It's 1, 2, and 4 here. This is 3, 7. That's 10, adding up with 6 to add up to 16 here. So that is valid there. This then adds up to, again, 15 or 16. So this is 8 or 9 here. And this must be 1, 2, 3, 4, 5, or 1, 2, 3, 4, 6. No 3 here. This is 2 here, which means this cannot be 2 here. This cannot be 8 and 9 as a pair here, because that would be 2. That would eliminate all possibilities for that cell. We have 1, 2, 3, 4, 5. We have all the 3s accounted for. We have to have a 2 somewhere accounted for. Okay, so these 3 digits add up to either 15 or 16 without 2, 3, or 7 available. This is guaranteed to be 1, 2, 3, 4, which means the remaining digits in this box must be 5 through 9. No 7 here. Okay, remaining digits in box 6 are 5, 8, and 9. These 3 digits add up to 16 without 3, 6, and 7 available. These add up to 13 with no 3 available. Remaining digits of row 7 we have, or actually box, let's do box 7. It's 3, 5, 6, 8, 9. No 3 here because of 3 in the column. Can we actually have a 9 here? The answer is no. 3 and 7 and 9 add up to 19. Right, 3, 7, 9 adds up to 19. And that's 2 digits can never add up to that. 2 unique digits can never add up to that. Same with 3, 7, and 8. So this can't be 8 or 9. We can't have 5, 6, 7. That's 18, and 2 unique digits can never add up to that. So we're guaranteed a 3 here. Okay. So that means this cannot be 3 here. So we could have 3, 5, 7, adding up to 15. And then this would be 6, 7, 8, and 9 as a possibility. No 7 here, obviously, so that couldn't be 8. Or it's 3, 5, 6 here. Sorry, 3, 6, 7 here, which would make that 9 and that 7. So those are the possibilities for this region sum line. This adds up again to 15 or 16 without 2 or 3. These add up to at least 11. Oh, this has to be a 7. It can't be, we don't have 1, 2, we don't have 2 or 3 available here. So this has to be 7 there. That eliminates 7 in the rest of the row. This can't be 7 here. That leaves a 7 there. So this adds up to at least 12, because 5 and 7 add up to at least 12. So at least 12 here, which means these are 3 through 9 as possibilities, but no 7 here, no 7 here. Okay. This can't be 2. We need another 2 in a circle. The only other possible 2 would be here. So this is 2, which means this can't be 2 here. We have 1, 2, 3, 4, 5, 6 7s already. So this must be a 7 here. So this is either 7, 8 adding up to 15, or it's 7, 9 adding up to 16. Also, this can't be 7 there. No 7 here. Where is 7 available in column 6? Can't be here or here because of 7's in the boxes. Can't be here because of 7 in the row. Can't be here because it must be 2 because there's no other place for 2 in the circle. So 7 has to be here, which makes that 3, which makes that 7. So no red there. 3 can't be here, nor here. 2 is here, 7 is here, 7 is here. We have all the 7s now available, or done. We have an 8, 9 pair in column 4, which eliminates 8 and 9 in the rest of the column. We cannot have 7 and 9 here. Because that would add up to 16, and then we'd have to have 7, 9 here, and 7, 9 here. We can't have 7, 8 here either, because if this is 7, 8, that would guarantee this has to be 6, 9 as a pair, and this would have to be 6, 9 as a pair, adding up to 15, but that would eliminate 6 and 9 as a pair as a possibility there. So this must be 7 and 5, or 7 and 6 here. And we have a guaranteed 5 or 6 on this line, so this eliminates 5 and 6 in the rest of the box. So this is an 8, 9 pair. Either way, if this is 7, 5, what would this be, essentially, is the question. If this is 7, 5, this would add up to 12. We don't have 6, 6 available. We don't have 5, 7 available, and no 3, 9, so it would be 4, 8, if that were the case. So this would be 4 and 8. If this were 7 and 5, this could not be 5 and 7. No 4 or 8 there, so it would have to be 3 and 9. So this would be 3 and 9. If this is 6 here, you'd have 7 and 6. No 6, 7 here. It could be 4, 9, or 5, 8 here in that case. 7, 6 here. Again, this could be 4, 9, or 5, 8. No 6, 7, though. And those are all valid. Okay. And we have a 4, 5, 8, 9 quadruplet in row 5, which limits 4, 5, 8, 9 in the rest of the row, so no 4 here. This can't be 4, 5, 8, 9. It's 1, 2, or 6 available. And this can't be 2 because of 2 in the column. So one of these would be a 6. And where's the 6 in box 5? It has to be one of those two. This adds up to 9, so it's 2 and 7. No more 2, 7 here because of 7 in the box. No 3, 6 here. So this is either 1, 8, or 4, 5, adding up to 9. To add up to 16, we have, okay, remaining digits in row 7. We have 3, 5, 6, 8, and 9. No 3 or 6 here. This can't be 5, 8, or 9 because of the 5, 8, 9 triplet in the column. So we have a guaranteed 8, 9 here. That means this cannot be both 8 and 9 here. So where's 8 and 9 in row 7? One of them's here, but the other one cannot be, so that means the other one has to be here because this 5, 8, 9 triplet eliminates 8 and 9 there. So we have a guaranteed 8 and 9 there. So 5 has to be one of these 3. How does this add up? So this combination, it's either 3, 9, 4, 9, 4, 8, or 5, 8. We're guaranteed an 8 or 9 in one of these cells, which means this is 8 or 9. That guarantees 8 or 9 in that 8, 9 pair. This 8, 9 being with one of these having to be 8, 9 eliminates 8, 9 in the rest of the column, so no 8, 9 here. We now have a 5, 6 pair in column 3, which eliminates 5 and 6 in the rest of the column. So this can't be 5 or 6, it's 3. That means this can't be 3 here. And this can't be 5 or 6. So this is either 3, 9, 4, 9, or 4, 8 here. No 5 or 6 here. We have a 5, 6, 5, 6 pair in box 7, which eliminates 5 and 6 in the rest of the box. So this is 8 and or 9. Where is the other 8 or 9 in column 1? It has to be on this line. So we have a guaranteed 8, 9 here, a guaranteed 8, 9 here, which means the rest of column 2 cannot have 8 or 9. It can't even have 7. So the remaining digits are 1 through 6, but 6 cannot be here because we're guaranteed a 6 in one of these two cells. Okay. This can't be 8 or 9 because of the 8, 9 pair in the column. So guaranteed 3 here. This cannot be 3 here. So we have to have this be either 4, 9 or 4, 8 here, which eliminates 4 and 8 in the rest of the column. So no 4 here. It's 1, which makes this 4. 1 and 4 eliminate 1 and 4 here, so that's 2. So no more 2 in this box. 2, in fact, has to be one of these 3 digits there. 3 has to be one of these 2 digits here. What else do we have? Can this ever have a 9 here? Again, these add up to 16. So that means these 3 digits must add up to 13. Well, if we have a 9 here, there could only be 9 with 3 and 1 to add up to 13, but we already have a 3 in the box being used. So this cannot be 9, which means we have to have an 8 here, because we can't have both 8 and 9 here. That already adds up to 17. So 8's there, which means this can't be 8. That's 9. So no 9 here. Means 8 has to be one of these two, which eliminates 8 in the rest of the box. So this can't be 8. That's 9, which makes this 8 there. So this must be 1, 2, 3, 4, 5, adding up to 15, which 7 and 8 add up to. And this must be 3 and 6 and 7, adding up to 16, which 7 and 9 add up to. 6 eliminates 6 here, so it's 5, which makes this 6. 7 and 6 add up to 13, so this cannot be 4 and 8. It's 4 and 9. That's 13 there, which leaves this as 5 and 8 there. 5 and 8 eliminate 5 and 8 in the rest of the rows. Those can't be 5 or 8. It's 9, which means this can't be 9. It's 4, which makes that 9. That eliminates 9 in the rest of the column. 8, 9 is a pair, eliminates 8 here. 8 here eliminates 8 here. So where is the 8 in column 9? It must be here. This is 9 here. And the remaining 2 digits must add up to 16 minus 9, which is 7. We don't have 1, 6 available. We don't have 3, 4 available. So this is 2, 5. And this can't be 5 because of 5 in the row. So that's 2 and 5 there. Which leaves just remaining 1 and 4 in column 9. And 1, 3, 4, 8 does add up to 16. So that satisfies that. We have a 1, 4, 5 triplet in row 1, which eliminates 1, 4, 5 in the rest of the row, so we're left with 6 and 9. This can't be 9 because of 9 in the column, so that's 6 and that's 9. 5 is guaranteed to be one of these two, so this can't be 5. 8 here eliminates 1, 8 as a possibility here, so this is 4, 5 to add up to 9, which is the same as 2, 7. No more 5 here because of 5 in the column. No more 8 here because of 8 in the column. So where is the 8 in row 7? It has to be here. Where's the 5 in row 7? It has to be there. That eliminates 5 there, so it's 4 and 5. And we have 1, 2, and 9 remaining in row 3. Well, this can't be 1 or 2 because of the 1, 2, 4 triplet in the column, so this is 9. And this can't be 1 because of the 1, 4 pair in the box, so this is 2, which makes that 1. 6 eliminates 6 here, so it's 3 and 6. That eliminates 6 there. Where is the 6 in row 4? It must be here. Remaining digit of box 3, we have a 5. And then we have 2, 3, and 6 remaining in row 2. And this can't be 6's because of 6 is in the column, so 6 is there. That leaves this as a 2, 3 pair here. Remaining digits of column 8 are 6 and 8. This can't be 6 because of 6 in the row, so that's 8, that's 6. Remaining digits of column 7 are 1 and 4. So we have a 1, 4 pair there. 4 eliminates 4 in the rest of this column. So this can't be 4, no 4 there. And again, this adds up to 15 now. So this must add up to 15 without 4, 2, 3, 4, 7, and 9 available. So I think it has to be 1, 6, and 8. Right, so 9 eliminates 9 here, so that's 8 and 9. 9 eliminates 9 here, so it's 8 and 9. And we have to have an 8 here, so it has to be 1, 6, and 8. And 6, again, cannot be anywhere except here in these two cells, so this must be 6 there. This is 1, 8 as a pair. That eliminates 1 and 8 in the rest of the box and column. 6 eliminates 6 here, so it's 2, which eliminates 2 there, so it's 1, which makes that 4. No 1 or 4 there, it's 2. So no 2 here, no 2 here. 5 eliminates 5 in the rest of the column. So this can't be 5, it's 1, which makes this 4, which makes that 5. 1 eliminates 1 here, so it's 4 and 1. And the rest is just normal Sudoku. 1. How many 1s do we have? Not enough. We don't have enough information. Well, we do actually. So 1 in box 5 cannot be here because of 1 in the column. So 1 is one of these two cells, which means this can't be 1. So that's 8, which makes that 1 there. 8 eliminates 8 here, so it's 5 and 8. 5 eliminates 5 here, so it's 3 and 5. But we still don't have enough information about 1s yet. 2s. 2 in row 9 cannot be here because of 2 in the column, and can't be here because of 2 in the box. So 2 is there. That means this can't be 2. It's 3 and 2 there. That gives us all 9 2s. 3s. In box 5, 3 cannot be here because of 3 in the row, so 3 has to be there. That gives us 8 3s, so the last 3 is there. 4s. In box 8, 4 cannot be here because of 4 in the column, so 4 is there, which makes this 1, which makes that 4. That gives us 8 4s, so the last 4 has to be there. We have all 9 5s. We have all 9 6s. We have all the 7s. We have all the 8s. And 9, we have 8 and 9, so the last 9 is there, which leaves the remaining digits as 1s. And that's a solution. Yep, fairly straightforward. Yeah, I would consider this probably easy. There's not that much going on that's too difficult. But it's not also trivially easy either, so easy sounds like a nice difficulty grade for it. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.